All right, in this video, we're going to look at the concept of loans for financial maths. So we've looked at savings accounts and how to set it up using a geometric series. For loan accounts, we have two options. We can set it up as a series, which I'm going to show you first, or we have a formula called the amortization formula, which can be used for all loan questions. You do have to be able to do both just in the event that they ask you to use one method or the other. So the way loan works is, for example, if we borrow, so I'm going to look at page 267, question number 10 here for the purposes of this. We are going to borrow €9,500 at an annual equivalent rate of 6.4%, and the loan is to be repaid in 4 years. We're looking at repaying monthly. So we want to know what is going to be the amount of the monthly repayments that will allow us to repay this loan in the 4-year period, okay? It works a little bit different to savings account in that the way loans work is the bank are charging you for giving you the money. So basically, when we make our first payment in month 1, we're going to make our first payment, and normally the way loans work is we make the payment at the end of the month. So we get our €9,500, say for example, at the 1st of January. On the 31st of January, we make our first payment to pay off our loan. That payment comes off the balance of the loan, but because the bank is charging us interest, it's not the full amount of the payment that comes off. So what we do is we look at the payment as the present value of making that payment. So our loan is gaining interest. So for example, if I pay €500 off this loan at the end of month 1, the balance remaining, the balance that I have to still pay off is not going to be €9,000. It's going to be more than €9,000 because it's going to earn back the interest in that month. Okay, so the way we set it up is we use the present value formula. It's just a rearrangement of the compound interest formula, but we're looking at P equals F over 1 plus I to the power of T. All right. T is the amount of months that the payment has had time to accrue interest in the account for. F is the amount of the monthly payment. P is going to be our balance of our loan at the beginning, and we're going to look at the sum of these number of payments, and obviously I is the monthly interest rate. So the first thing we have to do in a question like this is calculate the monthly interest rate, same as we did before, using our formula F equals P bracket 1 plus I to the power T. So we're looking at the 12th root of 1.064, which gives us our monthly rate of 0.00518. All right, we can't see that on my screen now, so I'm just going to write it underneath here. So our monthly rate of 0.00518, or 0.518%. So that's our monthly rate. And again, remember, we're looking at 4 years. So that is 48 months or 48 payments. Okay. So our balance of our loan is €9,500. Our first payment is going to take place at the end of month 1. We do not know what our monthly payment is. Let's call it X. But our monthly interest rate, 1.00518. Because the first payment is made at the end of month 1, it has had time to accrue 1 month's worth of interest, and therefore our power here is going to be 1. If our loan is repaid at the beginning of the month, which it never is, that first power will be 0 because the full amount of the monthly payment will be required. But because we're looking at paying it off at the end of the first month, we have had time to accrue the loan has had time to accrue 1 month worth of interest. Our second payment then is going to have time to accrue 2 months worth of interest, all the way up to our final payment is going to accrue 48 months worth of interest. So it works that's off my screen there. I'll just write that underneath here. Final payment, 1.00518 to the power of 48. All right, so this is how we set up our sum of our series. We're going to follow the exact same process that we did with the savings accounts, except this time what we are left with inside the bracket is going to be a fraction. So we have our 9,500 euro here. The common element is the x on the top of the fraction line. What we are left with then in our series, our first one, remember we're going to write it in ascending order, is 1.001 over 1.00518. Next one, 1 over 1.00518 to be squared. And final payment, 1 over 1.00518 to the power of 48. All right, so that's how we set up the sum of our series. We use the same formula, the SN formula. So SN equals A bracket 1 minus R to the power of N over 1 minus R. And I'm going to do this up here at the top so that I don't run out of space. So filling in my formula, we're going to ignore this here at the moment. We're going to fill in A is our first fraction, and this is where we need to be very careful, because when we're typing this into the calculator, we need to be careful to make sure that we type the fractions in very carefully, and that we also make sure that we type in all of our zeros very carefully. So A is the first term, R is the multiplier, so it's going to be the exact same. A and R in this case have the same value. So we're looking at S of 48 terms equals A, which is 1 over 1.00518, bracket 1 minus R, which is 1 over 1.00518 to the power of 48, over 1 minus 1 over 1.00518. Typing that into the calculator, being very careful to make sure that we have all of our fractions careful and correct. So 1 minus 1 over 1.00518 to the power of 48, over 1 minus 1 over 1.00518. That gives us a value of 42.4012896. Again, remember we write out all of the digits on our calculator. So going back to these figures now, we know that 9,500 is x multiplied by our bracket, which is our sum of 48 terms. So in order to get our x by itself, to find out our monthly payment, we simply divide 9,500 by the sum of 48 terms there. So 9,500 divided by the sum of 48 terms, which is already in our calculator. So 9,500 divided by our answer, and that gives us a monthly repayment of 224 euros and, correct to the nearest cent, 5 cents. So that's how we go about using the sum of a series to calculate the monthly payment of a loan. All right. We do have another option. The other option is the amortization formula. It's a formula on page 31 of our log tables. It's A is equal to P by I by 1 plus I to the power of T over 1 plus I to the power of T minus 1. Where possible, this is always the preferred option for dealing with loans because it's the easier of the two options. It creates an awful lot less work. So looking at our information again, our loan balance is 9,500. Our monthly interest rate is 0.00518. And we're looking at 48 payments or 48 months. In our formula, in the amortization formula, A represents the monthly payment. That's what we're going to find, okay? And bearing in mind now that we had a monthly payment of 224.05, we're going to see if we get the exact same figure. So A is our monthly payment. That's what we're trying to find. P is the principal of the loan, which is 9,500. I is the interest rate, which is 0.00518. 1 plus I to the power of T is 1.00518 to the power of T time frame, which is 48 months, over 1 plus I to the power of T, 1.00518 to the power of 48 minus 1. So those are the only pieces of information that you need to input into the formula. Typing it in, we have 9,500 bracket 0.00518. Again, make sure you are careful with your zeros. Bracket 1.00518 to the power of 48 over 1.00518 to the power of 48 minus 1. And that gives us a monthly payment of €224.05. So we do get the exact same figure as we got before. So remember, our figure that we got before was 224.05. We're getting the exact same figure, but it is a lot less work. But like I said, you have to be able to do both. So the key thing to take away from this video is when you are doing a loan through the sum of a number of payments, sum of a series, you use the present value formula. So that is P equals F over 1 plus I to the power of T. So remember, I is your monthly interest rate, F is your monthly payment, T is the time, the amount of time, the number of payments in total, so the time frame of the loan, and P is your actual loan, and so you're looking at your sum of your payments there. Alternatively, you use the amortization formula, which is Pi 1 plus I to the power of T over 1 plus I to the power of T minus 1. You don't have to remember any of these formulas. They're on page 30 and 31 of the log tables. You just have to be able to apply them. So in this formula again, P is the principal of the loan, the full total of the loan. I is your monthly interest rate, or weekly, depending on how often you're paying it back. T is the amount of time of the loan. So in that case, it was the 48 payments. If we're taking out a loan over, say, for 10 years, then we'd be looking at 120 payments if it's monthly. Okay. All right, so that's it on loans. I'll talk a little bit more about this, and we'll go through another couple of examples in tomorrow's Zoom class. Thank you.